Welcome back to the Simpkins Physics Corner, here with some F equals ma practicar. Vamos. All right, we're going to draw some free body diagrams, and we're going to get into, force of gravity. All right, so the force of gravity is calculated by taking something's mass, multiplying that by your gravitational acceleration, 9.8, and you get the force of gravity. Ooh, almost had a panic there. I thought I forgot my handy-dandy calculator, but no. I'm a physicist. So if the mass is 0.15 kilograms, Fg equals 0.15 kilograms times 9.8 meters per second squared. So the big idea for these first 4 problems, just to get you guys some practice here, is that weight is the force of gravity. You see, a lot of people will see, oh, mass. That's kind of like the same thing as weight, right? No, it's not. Okay, weight is the force of gravity. Mass is the amount of matter in an object, which we represent in the units of kilograms. So there's the first one. I'll let you do the next 2, and I'll just show you here again. Same dealio, right? So if the mass is 900 kilograms, then the weight, force of gravity, is m times g. So that would be 900 kilograms times 9.8 meters per second squared. And I'm a little hasty in my writing. You'll have to excuse me. But this is going to be 8,820 newtons. That's a beefy boy. Yeah, it is. So there's a little help for those first 2 for you. Let's go down. Calculate the mass of the following. Now, this one's asking us to find the m in kilograms, but it says a textbook with a force of gravity of 15 newtons. So that means that the Fg is equal to 15 newtons. Well, how would I set this up? Well, we're using the same equation, Fg equals mg. And a little side note here, guys, all right? This thing down here, this is called a subscript, all right? And what that means is a tiny little letter that just specifies which force we're talking about. So it's not F times g equals m times g. It's just Fg equals mg. That's a subscript. So some people like to plug in 9.8 there. That's not a thing, all right? That's just an identifier to specify what type of force we're looking at. All right, so now that we've cleared that up, let's go ahead. Fg equals 15 newtons equals m times 9.8 meters per second squared. Well, if you can algebra good, then you can divide both sides by 9.8 meters per second squared, 9.8 meters per second squared. And if you put that in your calculator correctly, we're going to be looking at a little something like 15 over 9.8 equals 1.53 kilos. All right, so there it is. That's how you get mass from weight. Weight. Force of gravity. How about this one? Solve the problems below while practicing showing your work and boxing your final answer. So how much net force is needed to accelerate a 5-kilogram potted plant at 2.5 meters per second squared? So meters per second squared are units for acceleration, or you could use context clues to identify that. 5 kilograms, what is that? Careful. It's mass, all right? So mass is 5 kilograms, there it is. And it says how much net force is needed to do that. Well, we know sigma F equals ma, or the net force is equal to mass times acceleration. 5 kilograms times 2.5 meters per second squared. That's going to be 5 times 2.5, which is 12.5 newtons. Now, the next few questions, this one's asking about acceleration, but you're using the same idea. And look, your list of knowns, it tells you what to do, all right? 20 newtons, and the mass is 8 kilograms. So, of course, you're going to do F equals ma to solve for your acceleration right there. Just have to divide both sides by the mass at some point. All right, so I'll leave the rest of those up to you. It's just plugging in for sigma F equals ma. The last page is interesting because here I want you guys to draw, here, read the directions. Label each force with what kind of force it is, tension, normal, gravity, friction, and the amount of force there is, a number. Okay, so if we have a 5-kilogram box sitting on the floor, we're going to have Fg down and we're going to have an Fn up. And we can say that because we're at rest, all the forces are balanced. And since the forces are balanced, that helps us do some things. Because it says calculate the force of gravity and the normal force. All right, well, wait. Force of gravity is mass times gravitation. That's 5 kilograms times 9.8 meters per second squared. And so the force of gravity down, 5 times 9.8, is going to be 49 newtons. So watch, when I say label with what kind it is and the amount of force, that's what I'm looking for. All right? For all these problems, you should be labeling the forces with what kind of force they are and how much force there is. Whoa, if the force down is 49 newtons and the force up is balanced with that, we know that because we're at rest, then the normal force is also 49 newtons. So there you go. There's your 2 forces for the first one. Not too bad. How about this one? A 2-kilogram cart is pushed along the floor. So we got Fg and Fn. Draw our forces and label them. The pushing force is 5 newtons to the right, so we'll call that, I don't know, FT if you want. All right, sometimes we call it FA. I should have put that as an option up there for the applied force, if it's like a generic applied force. But it says draw all the labeled forces and calculate the acceleration of the cart. So just like the first one, Fg equals mg, we're going to plug that guy in for 2 kilograms times 9.8 meters per second squared. And that's going to get us 2 times 9.8. That's going to get us 19.6 newtons for Fg. So there it is, 19.6 newtons. If it's on a flat surface, that means the upward force is also 19.6 newtons. Yeah, these guys have to be balanced. Okay, so that's cool. But think about it for a second. Up and down, they're canceling each other out. Is there a leftward force to cancel out our rightward force? Look in this direction, right here. Is there anything to cancel that 5? No, there's not, which means there's an unbalanced net force, okay? What is that force? It's 5 newtons, and it's exerted on a 2 kilogram object, so we're tasked with finding the acceleration for that object. We do that by dividing both sides by the mass. 5 over 2 gives us 2.5 meters per second squared. That would be the rate of acceleration that a 2 kilogram cart experiences as a result of a 5 Newton push to the right. So there's that, there's that, there's that. Yeah, good. We labeled all our forces. All right, we're good to go. We got all our answers in there. Last one. A 50 kilogram sled is pulled by dogs along the ground. All right, the pulling force is 250 newtons to the right. However, the snow exerts a friction force in the opposite direction. So it's kind of like dragging along the snow of 30 newtons to the left. And of course, we have the force of gravity down. We have the normal force up. Sorry, it's not floating off the ground. I don't know why I drew my line like that. There it is. And so let's label everything. Okay, so first, Fg equals mg. Hey guys, do you get the point yet? Fg equals mg. How many times have we used that in this video already? So we have 50 kilograms times 9.8 meters per second squared. There it is, 50 times 9.8 equals 490. So Fg equals 490 newtons. Label it. And if the normal force is opposing that, then that's also 490. Wow. Guys, it's like for every flat surface that's horizontal, the normal force and the gravitational force are the same. Yeah, that's right. Cool, so we got that. Now, how about this next one? This gets a little tricky, but not too bad. And sorry, can't type things good. All right, but the net force acting on an object is going to cause that object to accelerate. How much is it going to cause it to accelerate? Well, the net force is the sum of the forces. So let's take a look at our forces. We have 250 plus negative 30. Oh, why is it negative? Because it's going the opposite direction. So 250 plus negative 30, and I write it like that because technically this thing means add up all the forces, right? It's the summation sign from math class, and it means add everything up. So 250 plus negative 30 is 220 newtons. That's going to be equal to 50 kilograms times A. Divide both sides by 50 kilograms. And we got A equals 220 over 220 over 50 is 4.4 meters per second squared. So I hope that this was a helpful resource as you look towards our quiz on F equals ma and Newton's first and second law. Make sure that you check your answers with this in the video. Until next time, ladies and gentlemen, this is Mr. Simpkins in the Simpkins Physics Corner. Simpkins Physics Corner.